So we're going to start talking about trigonometry and angles. And so before we get there, we need to talk about what an angle is, how we measure an angle. So we measure angles in degrees. So I don't know if this is correct, but this maybe looks about 50 degrees. But what is a degree? Well, degree is almost like a fraction of a circle. So a full circle is 360 degrees going around. So any degree, like for example, this being 90 degrees, that is 93/360ths of a circle. So it's 90 degrees. So in trig, we deal with circles and we make little angles of this. So we always have our initial side going from the center out to the right. So that's 0 degrees. A straight line going across would be 180 degrees. Here we have a right angle, so that would be 90 degrees. And so if that's 0, 90, 80 down here, this is 270. And then we complete the circle to get 360 degrees. Now we have these lines in here which are common angles of a circle that we're going to look at when we talk about trig. This first one is 30 degrees. Second one is 45 degrees. And the last one is 60. And these may seem random, but what I can actually do is make a little triangle here. And if I draw this line straight down, I get a right triangle. Because this is a right triangle, this is actually a 30, 60, 90 right triangle. So I can find any of the distances, any of the lengths of the sides because of the rules for special right triangles. Now we're not going to be doing that right now, but this is why we look at these types of angles. Also here we have a 45, 45, 90 right triangle. There again is that right triangle with 45, 45 degrees. So special right triangles have these rules that we can get the sides for. So that's why we do 30, 45, and 60 as opposed to 10, 20, 30, 40, 50, 60, 70, 80, 90. So that's why these become our special or our common angles inside of a unit circle. And then we just count going around based off of this pattern. So notice these two dotted lines are 30 and 60. And so if we continue going around, we have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and finally 360. Counting for the 45s, the solid lines, we get 0, 45, 90, 135, 180, 225, 270, 315, and 360. So these are all of the common angles that if you've taken trig before, they may look familiar, and this is why we get them. Even over here, 150 degrees, if we make a triangle like this, notice this is still a 30, 60, 90 right triangle. So we look at these, and in each respective quadrant, we have two 30, 60, 90 right triangles and a 45, 45, 90 right triangle, helping us understand the relationship between the angles and the sides. Now there's another way to measure angles in a circle. And so what we do first is we talk about this scenario. So let's say I have a nice little lake and it has a radius of 1. Don't forget that a radius is defined as a straight line going from the center of a circle out to the edge. So that's 1 mile. And so I start here, and so I walk all the way around the circle. in a perfect straight line until I get back to my starting point. How far did I walk? Well, really what I'm asking for is the circumference, and the circumference for a circle is 2 pi r. Because the radius r is 1, the circumference is equal to 2 pi miles. So that's how far I walked. So let's think about that in terms of our circle. And we're going to call these measurements radians. So these are how we can measure these angles based off of a distance approach as opposed to the angles in degrees. So we start here, we go 0, and I walk all the way around, and that's 2 pi. So we're assuming that the radius here is 1. Well, halfway around that circle is just going to be 1 pi. So if this is 0, that's 1. This 90-degree angle is half of pi, so that's pi over 2. Going from 1 pi to 2 pi, in between is 1.5 pi, which is 3 pi over 2. And those you can kind of recognize as 0, 90, 180, 270, and finally 360. So let's find some more angles here. Well, if I could draw a straight line, it'd be really helpful. So I guess I'll do this. Let's just look at this top half of the circle and consider these dotted lines. So I have these dotted lines going across, and also the 90-degree lines. So the dotted lines and the 90-degree lines. Imagine that this is a pi. And I cut along these dotted lines in the 90-degree line. Now I have three slices here, 3 slices here. So this is 6 total slices in this top half. So that's why I count by sixths. So if this is 0, this is 1/6 of pi, which is pi over 6. This right here is 2 pi over 6, but 2 over 6 is 1 over 3, so that becomes pi over 3. This is 3 pi over 6, which are reduced to 1 pi over 2. This is 4 pi over 6, and 4 over 6 reduces to 2 over 3. This is 5 pi over 6, and this is 6 pi over 6, which reduces to pi. Continuing to count by sixths, I get 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, 9 pi over 6, which reduces to 3 pi over 2, 10 pi over 6, which reduces to 5 pi over 3, and 11 pi over 6, before finally adding the last pi over 6 to get to 12 pi over 6, or 2 pi. We can also count going for halves. So this is half of pi, and this line is half of that. Well, what's half of a half? Half of a half is a quarter or a fourth. So this is pi over 4. So I do pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, which is just 3 pi over 2, 7 pi over 4, and finally 8 pi over 4, which is 2 pi. So going around this circle, I have these angles that look familiar. So for example, this first one here, pi over 6, well, that's the same as 30 degrees. So pi over 6 radians is 30 degrees. So there are 2 ways to describe an angle. We can have the radian measure, and we can also have the degree measure as well. So knowing that, it's going to be very important for us to convert between the 2. So in order to convert, we need to use conversion factors. So let's think of some radian measure. Let's say 5 pi over 12. And I want to convert this into degrees. Well, I want to convert this and I want to multiply this so I have degrees, and I want to get rid of this pi radians. So this is what we call a conversion factor. So pi radians, pi radians. When I multiply, the pi radians will cancel out, and I'll be left with degrees. Well, if I keep it simple and do 1 pi radian, there are 180 degrees in 1 pi radian. So when I multiply, the pi's cancel out, and I'm left with 5 times 180 over 12. And so 5 times 180 is going to be a 900 divided by 12 is 75 degrees. This right here in red, that's what we call our conversion factor. Because notice 180 degrees is the same as 1 pi radian. This is equivalent to 1. So we're not changing the value of this fraction. All we're doing is changing how it looks. We're changing the radian measurement to degrees. Likewise, we can do the same thing for degrees to radians. So let's do something like 50 degrees. 50 degrees. And our conversion factor this time has degrees here, so we need to put degrees in the denominator. And we put 1 pi radian in the numerator. So degrees cancel out. So I'm left with 5 pi over 18 radians. That's my answer. Yet again here in red, that's our conversion factor. Notice these two are equivalent. So this fraction is actually the same as 1. So converting is really simple, and a lot of people get confused because they're just not thinking about it. But actually think about what you have. So here, if you do pi times pi over 180, you would actually get pi squared over 180 degrees. Well, you didn't get rid of the pi radians, and you still have degrees. So you have to think about what you're going to get. Like here, if I have a pi in the denominator and I have degrees times degrees, that's squared degrees. That's not what I wanted. I wanted just radians. So understand the conversion factor and really the key concept of cross-canceling when multiplying fractions. Now, one quick other piece of information is a coterminal angle. So a coterminal angle is an angle that shares a terminal side. So here's an angle. Remember, we start from the center of a circle, go to the right. That's our initial side. And then the other side is going to be called the terminal side. So here, that's an angle. But what if I also went a full lap around the circle? That means that this is really two angles that share a common side. So let's say that this one is 130 degrees. Then this other one is 490 degrees. How do I know that? Well, I just added a full circle. I went from 130 and I added 360. So to find coterminal angles, when I have degrees, I'm going to do the angle plus or minus 360 degrees. Why minus? Well, we're going anti-clockwise or counterclockwise, which represents a positive direction. But if I go the clockwise direction, that's a negative direction. So what I could do is also subtract 360 degrees. So that would also give me negative 230 degrees. For radian measure, I would have x radians, and I would just add or subtract a full circle, which is 2 pi. And that's it. So a lot of people like to convert before they do this addition or subtraction. So for example, they'll convert from radians 2 degrees, add or subtract 360, and then convert back. But the conversion is really unnecessary. All you have to do is add or subtract 2 pi. So let's look at some examples here. So first off, let's just do some basic conversions. So here, this is in radians, and we want to convert this to degrees. So because I have pi radians there, I'm going to put pi radians in my denominator and multiply by 180 degrees. Here the pi's cancel, and actually I can reduce the 9 and the 180 as well. So the pi's cancel, this goes away, so that becomes 20, that becomes 1. So what I actually get is 140 degrees. Simple enough. Right here, I'm going to multiply this by pi over 180 degrees. The degrees cancel out, so I'm left with 265 over 180. 265 pi over 180. But of course we can reduce that, so we need to reduce that. So if we reduce this, if we simplify this, we actually get 53 pi over 36. Here to find positive, we want to find one positive and one negative coterminal angle. So 225, if we add 360, we are going to get 585 degrees. And if we subtract 360, we're going to get negative 135 degrees. Simple enough, right? All we do is add or subtract 360. Here, we are going to add and subtract, well actually, so we want to add or subtract 2 pi. But actually 2 pi in this case is 6 pi over 3. So if we get negative 7 pi over 3 plus 6 pi over 3, notice it's still negative. So there's my negative coterminal angle. And so if I add 6 pi over 3 again to that negative pi over 3, I'm going to get 5 pi over 3. There are an infinite amount of answers for these. So if you wanted to, we could subtract 2 pi from here, and we would get negative 13 pi over 3. But if I add the 2 pi, I'm still at negative territory, so I'd add to need another one anyway. So that's why adding twice would give both answers there. So this is just a real basic introduction to trig. Coterminal angles, degrees, and radians, and converting between the two. So make sure at the very least you are familiar with this, how we get these radian measurements and their positions, and also these common degrees. But more so these radians, because in future lessons what we will be doing is looking at the coordinates where these lines hit the circle on a coordinate plane.